All right, so we're finishing up chapter 5, isoquants and marginal rate of technical substitution. Isoquants, remember, they capture the trade-off between two things, and so this chapter is specifically between the combination of inputs, capital and labor, combo of inputs. That, and then this is the important part, will yield the same output in the long run. So why is the same the important part? Well, because that's what ISO means, right? ISO just means the same. So that's where that notion is coming from. So isoquants, if we look at our graph, we have a trade-off here between capital input and labor input. What are they going to look like? Let's see what it's at. And so there's going to be a curve here. There'll be another curve above it, right? They're not touching, they're parallel to each other. And we could just say there's one more. So what does it mean when you get it further up and to the right? What does each curve represent? Each curve is a combination of two inputs, but the curves aren't representing a certain cost, like it costs $1,000 to run this one, or $2,000 to run this one, or $3,000 to run this one. What are they representing? So what is the definition here, right? The trade-off between the inputs, capital and labor, that will yield the same output. So these are all outputs. Does that make sense? So this is Q1. So this is like, 100 units of the final product. But it's not necessarily in terms of the same cost. It's in terms of the same output. So this is Q2. This, we can say this is for 200, and then this is Q3, which is 300, right? So the more we go to the north and to the east, right, there's going to be more output. Very good. And so I know we're not very familiar, nor are we very comfortable with, doing things outside of 2 dimensions, right? And this is really a kind of 3-dimensional problem in a way, right? Because not only do we have the dimension of K, but we have the dimension of L and also Q. And so the way to think about this is, like, you guys have all seen a topographical map, right? Where, the top of the plateau or whatever, that's 400 meters. And then this part of the plateau is 300 meters. And this part is 200 meters, right? You guys understand what I'm saying here? And this part is 100 meters. So this is all the height of it. And then, so this is looking down on it, right? Looking down. If we were to look out at this same figure, it would be something like this, right? So you guys are following my whole notion here. So it's the same kind of thing. We're rotating this on its side, and that's what we're seeing with the different isoquants. So we're seeing different levels of, like, a mountain or something. Does that make more sense now? Okay. So how does our marginal rate of technical substitution come into this? Well, let's start a new page. Our marginal rate of technical substitution is what? This is the rate at which producers can substitute between 2 inputs. So for this case, capital and labor, right? And maintain the same output. So we know, and we did some questions about this in class on Wednesday last week, right? We know that the marginal rate of technical substitution between capital and labor is equal to marginal product of labor over marginal product of capital. We know that the marginal product of labor, if it's either a linear or a a linear or a Leontief function. Who remembers what a Leontief function is? It's where it's the minimum of the two, right? It's where each input, yeah, it's like exactly, it's like the strict L's instead of the curvy ones. So for both of those, it's just the coefficient, right? Because they're just linear. So when it's, sorry, it'd be helpful if I use some examples, right? So when it's Q equals 7L plus 4K, right? Then this 7, that's the MPL. And this 4, that's the MPK. The same thing if we have Q equals minimum 7L comma 4K. This 7 is the MPL. And this 4 is the MPK. The one that's different, right, is the Cobb-Douglas production function when we have something like 4 times L to the 7/8 K to the 1/8. Right, so this is the time where we need to do the partial derivative, right? So if we hold one of them constant, so if we're doing, why don't we just do it right now? So quick review before we jump back into our lesson for today. So quick review. So what's our marginal product of labor? It's going to be the partial derivative of this dual with respect to the labor, right? So what does that mean? That means the capital, I'm going to just kind of copy and paste that in its own special little box and not do anything to it. And then I'm going to do the derivative of 4L to the 7/8, just like it was normal. So real quick, why don't we, in the side, just do the derivative of 4x to the 7/8, since we're all way more used to dealing with x, right? And so how do we do this? Well, we use our power rule. So we're going to take this 7/8 down. We're going to multiply it by 4. And then we're going to subtract 1 from the exponent, right? From 7/8. So I'm just going to write 7/8 minus 8/8, just to save me a little time. 4 times 7/8, the 4 and the 8 cancel out. And so we just get 7/2, which is 3.5. So it's 3.5x to the negative 1/8. So we can just go ahead and put that over here, times 3.5. Now it's not x though, it's k. Thank you. It's L to the negative 1/8. And then if we want to clean this up, we would end up with 3.5 k to the 1/8 over L to the 1/8, or if you're like me, you can put both of those in parentheses, right? This can just be equal to 3.5 times k over L to the 1/8. So that's the marginal product of labor with the Cobb-Douglas, right? Note that it depends not only on the capital stock, right, in terms of what we're employing, which makes sense, rationally. Like if we're looking at how much does an extra labor add, you have to see where you are in terms of capital. Have you already upgraded the pizza ovens if you're making pizza pies and stuff, right? Like how much capital do you already have? And then also, it depends on the labor that you're at, your labor stock right then. So these other two are really not representative of reality. The Cobb-Douglas one is the most representative of reality. These two are just, easy points on the test / stepping stones that help y'all understand the Cobb-Douglas function and what's going on. Okay? So I highly encourage you to do the marginal product of capital on your own, and we'll do it at the beginning of class on Wednesday. Okay. So the marginal, let's get back to how this all deals with the isomorphs. So let's go ahead keep that up, stay in over it. So we're going to have a very similar, there you go, capital input and labor input. And we're just going to deal with one isoquant, right? Because it's going to be kind of confusing to do more than one. And we're specifically going to be looking at going from point C to point, sorry, point A to point B, and then point C to point B. First solution. So A, B, this is going to be a change in the capital. One, this is going to be a change in labor equal to labor. And so when we're down here, we have the slope of this is going to be equal to the change in K over the change in L. So that's going to be -1 over +1. Or sorry, +1 over -1. Thank you, G. And that's going to give me -1. And so that's the slope of these isoquants is the marginal rate of technical substitution. So that's equal to, and it's actually, this is kind of annoying, it's equal to the negative of the marginal rate of technical substitution. And this changes as we go to different parts along the slope, right? Because why? This is a kind of production function makes this. So we know that this is the production function for Leontief. And the linear ones look like this. So it's got to be so this is the Leontief. This is linear. And this is all talked about on page 147 of the text. And it's figure 5.4. 5-4. So this is going to be a Cobb-Douglas function. And remember, the Cobb-Douglas is the most representative of reality. So the rate at which we can change our capital for our labor and keep the output constant is going to change depending on how much capital and labor we're currently employing. So when we go from point A to B, it's a 1-for-1, right? But then when we go from point C to point D, when we go from point C to point D, we're giving up 1 unit of labor again. And we're gaining, we're utilizing, we're now going to be using 3 more units of capital, rather than before it was just 1 more unit of capital. So, what's our marginal rate of technical substitution as we get closer and closer to the capital axis in our graph? It's going to be the change in K, which is 3, +3, over the change in L, which is -1. So we end up, oops, sorry, this is negative. So we end up with a marginal rate of technical substitution that's actually much higher than it was before. And this would happen too if we went closer to labor. So as you get closer to the axes, it costs more and more in terms of what you're trading off 1 laborer, but you need to hire 3 more capital. And if we were, if we extended this all the way down here, right, we would see that, adding 1 more labor right here is going to, the amount of capital savings that we would get from adding 1 more labor right here is almost nothing. Does that make sense? Because the slope, and so it's an artifact of the exponents in the Cobb-Douglas thing. The fact that this 100, Q equals 100 equals capital to the 3/4 labor to the 1/4. So it's the reason why it's built in is what I want to say. But it is a good reflection of reality, right? That we have diminishing returns to our inputs as we use more and more of those inputs. So questions on that? Okay, so now's where it gets tough. I know. It wasn't tough before. This is probably the toughest, okay? So just bear with me. So now we're going to talk about ISO cost, right? So we talked about ISO quants, right? ISO quant means same quantity, right? ISO quant. Now we're going to talk about ISO costs, okay? ISO cost is a combination of inputs that yield the same cost. This is what you were defining earlier. So in order to have an ISO cost, instead of it being, so before, right, with the ISO quants, it was something like, 100 equals Q to, or sorry, not Q, K to the 1/4, L to the 3/4, 200 equals K to the 1/4, L to the 3/4, right? And that was related to each one. Now, ISO costs has to do with the fact that the wage rate times the labor, right? Because this is my total wage bill. Plus my rental rate times my total capital stock I'm employing, right? Because this is my total capital bill, is going to equal some costs. R times K. And R is the rental rate of capital. So if you bought the capital, then you just act like you're renting it for yourself. And so ISO costs change when what happens? These change when input prices change. And as a rule, for given input prices, ISO costs further from the origin are associated with what? Higher or lower costs? Higher. Think about it. They're using more resources, right? So therefore, it's going to be higher costs. So, how do we combine all this together? I know you're dying to figure out how to combine all together. Well, what was the ISO quant curve on? It was on an axis of capital on the Y and labor on the X, right? Just a convention. But because that's the convention, what do we need to solve for when we're rearranging the ISO costs equation so that we can then graph our ISO costs? So if we want to graph this onto this particular set of axes, and right, this, the horizontal axis is L and the vertical axis is K. What do we need to solve for? Or what do we need to have this cost equation in terms of? So when we usually have, well, so remember the inverse demand equations? Can we do that here? Solve for the inverse demand? Okay. And so you were given something in terms of P or in terms of Q, and you just have to solve for something else. So in order to graph something, you have to solve for whatever's on the y-axis, right? So normally we have graphs and it's all x and y, right? And we're given, but sometimes what if we have something like, you know, we're given the x minus 2 squared plus y minus 2 equals 0, right? Then we have to solve for y in order to be able to graph it, right? So it's the same kind of thing going on here. We have to solve for k so that we can graph it on here and we can put it all together. Does that make sense? So how would we solve for k? We just move WL over to the other side, and then we divide everything by R, right? So this is going to be k equals C over R minus W over R L. Does that make sense how I got to that? Okay, cool. Moving on. Yeah. It's because you got to divide everything by R. Because we already took WL to the other side. Oh, just for convention. It means the exact same thing. Yeah, yeah. It's because W and R are parameters, so they're usually given. Like the wage is $12, the rent rate's 30 cents, and the L is the thing that we're actually like. It's the X, right? It's the variable. So even though they're all variables, some of them are what are called parameters, which they're like things. Does that make more sense now? So that's why I group them together. That's a great question. Okay, moving on. So now that we have it in terms of K, we can go ahead and graph it. Capital input, labor input. What is the y-axis going to be? C over R. How did you figure that out? L equals 0, right? So he did K of 0, right? So then he evaluated minus W over R times, and then instead of L here, he put 0. And so then that zeroed out this whole term, right? And then it's just K equals C over R. So the K-intercept is C over R. What about the L-intercept? So the L-intercept, we want to put the K for, the K is equal to 0, right? So that'd be 0 equals C over R minus W over R times L. And then we can add W over R times L to both sides. These annihilate each other. We get W over R times L equals C over R. We can go ahead and multiply both sides by R to cancel out those ones on the bottom. And we end up with W times L equals C. And then we end up with L equals C over W. So that's our L-intercept, C over W. And then because it's just a straight line, we just connect the dots, right? K equals C over R minus W over R times. Because even though it doesn't really look like a straight line, right? Like W is always a constant, R is always a constant, C is always a constant, right? By definition, it's an isocos. So C is for constant, C is for cookie. And the C is always constant. So it's just a straight line with a slope of negative W over R, right? So, like I said before, if we have a line that's to the right, and that means it's going to be more expensive. And then lastly, what would happen if the wage rate were to increase? If the wage rate were to increase, let's say that we started at this black line. If the wage rate were to increase, it's going to pivot. Nothing's going to happen with the capital intercept, right? Which makes sense because that's talking about the cost when labor is zero. So if the labor wage rate increases, why would that change at all? But this is definitely going to change, right? So that's going to pivot in. And so this is C over W2 when W2 is greater than W1. So at the end of the day, we cannot forget that for producers, profit maximization is the same as cost minimization, right? And so what's our cost minimization rule? We're going to produce at a given level where the marginal product per dollar spent is equal for the labor and the capital. So the marginal product per dollar spent in labor, so we're taking the marginal product, we're just dividing by the wage, so it's per dollar instead of per hour. And then the marginal product per dollar of capital. And so the other way that we can represent this is we can say that the marginal product of labor over the marginal product of capital, which is what our marginal rate of technical substitution, right, should equal the quotient of the wage rate and the rental rate. So what does this look like graphically? So we already did a little bit of this in class at the end on Wednesday. But what does this actually look like? So let's put it all together. We've got capital input. We've got labor input. Let's go ahead and make an isoquant line here where Q1 equals 100. We've got a ISO cost curve. So the first ISO cost curve we have is going to be right here. And then the second ISO curve cost. Okay, so we know that the slope of this, right? The slope of this curve is equal to what? The negative marginal rate of technical substitution. And we know that the slope of these curves is W over R. It's negative W over R, right? So what's our cost minimization rule? Right, so remember the negative MRTS is just negative MPL over MPK, right? And so we want to find the point where those two are equal to each other, right? And so we see, but because of the nature of, you know, these graphs and stuff, right, there's actually going to be multiple points. So we're going to have point A, we'll have point B, and then we'll have point C. So which is the cost minimizing point? Because all of those are points where the slopes are equal to each other, right? In terms of the So, you know, negative W over R is equal to negative MPL over MPK. So the negatives cancel out, and boom, that's our cost minimizing rule, right? So all of these points technically are meeting that cost minimization rule, right? So how would we choose which one is actually minimized? It's C. Why is it C? What's going on? That's the golden question, right? What's going on, so what is this? This is a cost line 1, and this is a cost line 2. What do we know about ISO costs? For a given set of prices, ISO costs further from the origin are associated with higher costs. So even though it's meeting our cost minimizing conditions, it's a cost minimizing condition for that ISO cost curve. So you want to get to the lowest ISO cost curve possible, right? Because what's actually happening? What's actually happening is there's an infinite amount of ISO cost curves here, right? And so it's going to keep jumping to a lower and a lower and a lower and a lower ISO cost curve until it hits that fat light blue line, because that's the one that it's tangent to. It's just touching it just one time. So that means they're going to get the most amount of production for the least amount of costs given the current input prices, namely the wage and the rental, right? That's what's determining my points over here. C over 1, sorry, C2 over W, C1 over W. This is C1 over R. This is C2. Oh crap, I did that backwards. C2 over R. This is C1 over R. And then again, the slope of all this stuff is just W over R, right? So you will be given those values in the problem at the end of the book or in the test, right? You'll be told the wage is this, the rate of capital is this, they're using a Cobb-Douglas production function. What's the cost minimizing one? So questions on that? I think that should help conceptually now, but we've probably just been running through the steps a bit methodically, right? But I don't think it's too abstruse. It's not incredibly important for you to understand it conceptually in terms of testing and stuff, but I think it's important in general. This is at the core of all graduate level economics analysis. That's micro oriented on firms or people. So there's a very, very similar situation going on with individual people. Instead of production, it's utility, and instead of capital and labor, it's the amount of time working and the amount of leisure. It's a similar kind of thing. Like you get leisure, you get utility from leisure, you get utility from working, but if all you do is work, you don't have any time to play, right? So that's why there's a diminishing returns to your enjoyment of work. But if all you do is chill and you don't work at all, you don't have any money, you know, and since the nature of the world is, you know, you need money to do things, right? So there's diminishing returns to leisure too. And so there's a sweet spot, right, in terms of how much of our day or week or month is spent working. Does that make sense? It's exactly the same framework as what we're using here for analyzing cost minimization for producers. Absolutely the same, just a different setup and different parameters for maximizing our happiness by rationing how much time we're spending working in it. I know, gee, it's a little foolish, but it's a simple model, right? All models are toy models, so they all have some simplistic elements to them. Unfortunately, we just gotta make do. Questions on this process? Okay. We've already gone over a lot of costs and things like that, the cost curves. just want to reiterate, right? What do we do with sunk costs, Don? Yeah. Right. So do we include them when we're making decisions in the future? We do not, right? We ignore sunk costs in order to maximize our profits or our losses. Right. Okay. Cool. And we already went over long-term average costs. We went over business scale losses. We move on to chapter 11. Questions? Yeah. So now you're talking about the fact that, so this is, no, this is a bit, you bring up a very good point, and it's the fact that right now, the way that we're envisioning economic problems and the solutions to those problems is we are envisioning them that they are what is called one-off. One-off meaning happens one time, I never expect to have to deal with that kind of thing again, right? However, most things in life are actually repeated, right? And so when we get to discussing oligopoly, and we get to discussing the different pricing behaviors that different, so like the pricing behavior that PlayStation and Xbox has in terms of the prices that they make for their games and everything like that, right? That is driven by what's called game theory. And so when we're no longer just looking at things as contemporaneous, when we're looking at them, they have a time element to them, right? Then we're really starting to deviate from what is, technically the domain of neoclassical economics into heterodox, so a multidisciplinary approach to economics. And that's, we'll get to a little bit of that when we talk about the Corno and the stack over oligopoly games. But you bring up a very good point. Right now, we are overly simplifying matters by thinking that we're not going to be in a similar situation in the future. And yeah, if we were to spend the time to write ourselves a note or to fix the, like the class, if something's wrong in an online class, right? I could either write myself a note for next semester, or I could just fix it right now. So the next time I do it, it's, you know what I mean? But I would only do that if I'd expect to teach that class again. If I decided I was going to leave this place after this year, you know what I mean? I wouldn't do any of that stuff, right? Because it's a one-off game, and I would be trying to optimize my future and not think about the fact that, oh, that activity or that forum post, was really counterproductive or a waste of time. Does that make sense? Okay, cool. And you bring up a very good point, and you're thinking in the right way. So, Chapter 7 talks all about the different nature of industries and market structure and things like that. It's fairly qualitative, so I don't think it'll actually take us too long. But essentially, what are the different market structure factors that could influence if I was a manager, that could influence my decisions, right? So market structure. What are the things that influence or impact my decision as a manager? Yeah, so that would be the first one, the number of firms. Yeah. Entry, free ease of entry and exit. Resources, very good. Costs. Customers, very good. That'd be demand conditions. How do we get all those resources and put them together to make this stuff? Do we just like the technology? Exactly. homogeneous and heterogeneous, yes. So homogeneous, right, it's discussing a situation where they're all the same type of firm or they're all the same type of thing. Heterogeneous means that they're of different types or of different characteristics. Does that make more sense now? I think we're going to get to that. The last one, yeah. That's a great point. But is it free? But is it free? I mean, it's supposed to be, or they're ostensibly, right? They have free market policies or whatever, but yes, no, absolutely. And this is completely left out of neoclassical economics. And there's actually a type of economics called institutional, or they're like, yeah, something like that, economics, which specifically it's tied in a lot with developmental economics because oftentimes the countries, so it's not always, but they're often intermingled because it's not just the demand and the technology and the cost, but it's the fact that, so, for instance, like when I went down to Colombia for this investment fund and checking out different properties in different places to go invest money, one of the things that we were looking at in terms of the market structure factors that influenced our decision whether or not to invest money and help these people expand was a logistical / institutional concern, right? In terms of, so what? So you make all this stuff, but you're out here in the middle of nowhere. How are you actually going to get it on the roads to a shipping port when the roads between here and there are notoriously, it's a red zone. Like the cartels own those roads. So the cartels are gonna, hold you up, right? Or demand a payment or something like that, right? And these were not facts that a lot of people were necessarily looking at, right? And that's so. But even if it's not necessarily so in your face or violent or something like that, right? It could just be, the UN, I think, one of them, they have an index called the Ease of Doing Business Index, and that literally is an index of how much craft is necessary to get typical things done in the government, right? And so we kind of take it for granted that, we expect to live our lives without ever having to bribe a government official to, be seen in court or have our contract enforced or something like that, right? Now, I'm not saying that there is not bribery or there is not graft that's going on. It is happening. That's a different story. But the typical person or the typical business owner doesn't pay for it, doesn't participate, right? In other countries, it's literally just another cost in everyday business, right? And so that's absolutely, these institutions are a huge factor in terms of maybe not your decision, but the consequence of it. So it should be a part of your decision because they're having a very what we would call an outsized influence on the results compared to the other things, right? So yes, that's a very good point. The last one that we did not get, though, is the concentration of firms, right? So not just the number of firms competing in the industry, but call this 1B, the concentration. So how large they are, the relative size of them, right? To jump into the online retailing marketplace world in the early 90s, would have been a really good, before Amazon and everybody else was into it, right? Would have been great, but now there's so many firms competing, and one of them has 60% of the market share or something like that, right? Or if we wanted to get into advertising or something like that, right? Like it's completely duopolized by Google and Amazon. And so that's another influence in terms of our decision to either enter, exit, expand in that industry, so on and so forth, right? So how do we actually measure the concentration, right? So how do we measure industry concentration? And here's where we will leave off for today. All right, so measuring. And we will start off in class on Wednesday doing some problems from the back of chapter 7. So say we have 4 firms. Let there be 4 firms. We can make a 4-firm concentration ratio where it's S1 plus S2 plus S3 plus S4, where it's the sales of each one of those companies all over the sales of the total industry. So we want to see how much of the total industry is dominated by these top. And there's a specific index that we will get lots and lots of practice using. The Herfindahl-Hirschman index, also known as the HHI. And this is scaled, multiply 10,000 times I equals 1 to N, where N is so many numbers of companies in the industry, SOI over ST squared. So we will do many examples of this in class starting on Wednesday with some real world counterparts, so it won't just be so esoteric and vague. All right. Good luck studying. Please send me emails with any questions or problem areas you guys might have. The test is coming up. It's going to be due this Sunday. You have 2 attempts. You'll take the best of the 2 attempts. 70 questions in 120 minutes. Some students do say that the calculations do take a little time. You might just want to take it strategically. If you're not strong at calculations, just skip those and come back to them at the end if you still have time, right? But please let me know how I can help. Any extra videos you guys might want, just email me. All right, have a great rest of your Monday. What's up, Grace? Yeah. Will you shoot me an email? Just remind me. Okay. Right. Yeah. I'll send you more practice. Just send me an email. And specifically like what day or what class or whatever. And I'll go back through the YouTube and find some for you. No problem. Thank you, Grace. Thanks for letting me know, man. See you guys on Wednesday. Have a great day.